the study of groups presented by generators and relations, studies how groups are built and their properties deduced from these
It's
presentations.
defined by the algebraic equations y squared
It first
x
appeared in the study of discrete groups and the fundamental group concept.
We get that y squared.
Group theory has some strong connections with representation theory, by the way.
Algebraic geometry
Anyway,
begins the studies of zero
Fourier
and
analysis.
equations. But at the same time, it has a
Fourier
reputation
analysis mostly focuses on how functions or signals can be expressed as sum or integral for basic oscillatory functions,
It's really about the bridge, algebra.
like sine and cosine waves, or more generally speaking,
Consider
complex
the
exponentials.
x squared plus y squared.
Basically, it's all about manipulating the functions through their frequency conversion. If you're enjoying this video, don't forget to like it and to subscribe to the channel.
For example,
Real analysis in complex numbers.
and returns just the y.
Real analysis studies real numbers and their functions. It goes into limits, continuity, integration, differentiation, and series to understand the foundations of algebra. Complex analysis, though, extends these ideas to functions with complex
And
numbers.
so,
It studies properties like analyticity, contour integration, residues, and conformal mechanisms.
还是吴董，就是基本上你只要在台面上看到，我就先喷你。
Dynamics.
to minus 1 over 2.
Dynamics, or dynamical systems, is the study of how systems evolve over time. This includes both discrete and continuous systems. Discrete dynamical systems operate in jumps over distinct and separate points in time, such as the steps in a numerical
Are
function.
actually the same as functions
Continuous dynamical systems deal with
G
things
of
occurring
1 over
over continuous
1 over
time, which looks like natural processes,
and G of this
like
point
motion and
is
gravitational
minus 1.
force.
Notice that these are the same outputs produced by our function f of x y.
Partial differential equations.
The same will be true for these two functions. They are the same
Partial
as functions
differential
of the unit.
equations, or
More
examples,
generally, any function
distinguish
of this
themselves by the
form
presence of partial
will be the same
derivatives.
as f of x y.
They indicate the rate of
Let's break
change
this
of
into
functions relative to multiple
The set of
independent variables.
polynomials in the variables x and y.
This class includes a really wide spectrum of equations, each of which models completely different
This is
scenarios.
more than just a
For
set.
example, the heat equation models the distribution of flow
Add the
of heat in a
polynomial
medium over
coefficients,
time,
you get a polynomial with real It's also
while the
true
wave
for
equation
multiplication.
describes the propagation of
An
waves,
algebraic object
like
is a
sound
wave
or light
function.
waves through space.
Now look at the set R of all polynomial functions
Functional
defined in
analysis.
the unit circle. If you think of two polynomials
Functional
as
analysis
defined
studies
as the same
infinite
function,
dimensional
if
vectors,
they agree on all
like
points
Banach
x
and
y,
Hilbert, and linear operators
they are
acting
equal
on
to
them.
the numbers R.
闭嘴，不要跟着
It
唱。
combines
add
techniques to
multiple
investigate convergence, continuity,
Therefore,
spectral properties,
R is a
and
ring.
duality. These insights are applied
Some
across
terminology.
different areas
This
like
ring
quantum
R is
mechanics.
called the coordinate ring of the circle. We view it as an algebraic manifestation of the circle.
Enumerative and algebraic
As we
combinatorics.
see, geometric properties of the
Enumerative
circle are
combinatorics
included
is one
in
of
the
the oldest
algebraic
branches of
properties
math,
of its coordinates.
focusing on the straightforward task
A
of
smaller
counting
size.
configurations
For
or
those who know
structures.
some ring theory, you'll realize that the ring here is working with
It's
the
done by
quotient
establishing bijective
R bracket
correspondences that
modulo
simplify
the
this
idea
counting
generated
process.
from x squared plus y squared.
Algebraic
words
combinatorics,
don't make
which is
sense.
a more modern development, uses algebraic structures like group theory to solve combinatorial problems,
Y plus x equals
extremal and probabilistic combinatorics.
0. X plus y squared equals 0.
The foundational technique
The first
here,
word is a
the
union.
probabilistic method, involves
And the
showing
second
the
word
existence of a combinatorial
We say that this
structure
curve
that
is
fulfills
reducible.
certain properties by showing the probability of randomly selecting a structure like
R
that
be
is
the
non-zero.
First term. And let S be the ring of functions. Second term. The algebra
Numerical analysis.
is given.
Numerical analysis deals with the development and
Consider the function
implementation
f
of
of x
numerical
y.
methods to solve mathematical problems.
It's not identical.
It deals with very important
example,
concepts such
f
as
of y
error
equals
analysis, stability, and convergence.
Similarly,
These concepts
function
are
g of
very,
x y
very important
equals y
because they
minus
help
x
us to
is not
evaluate
zero.
the effectiveness of numerical algebra.
product
怎么
is
能
zero
这样子
on
嘞
all？points
怎
of
么
the
能这样
curve.
子嘞？
This type of
那这
behavior
样
might
子
be
嘞，对不对？
the
Set
product
theory.
of things is zero. But both
The study
fact
within
are
this
non-zero.
field focuses on understanding how sets
马
operate,
上
It turns
interact,
out
and can
this
be
does not immediately
characterized in
obvious.
terms of
The
the
product
type.
of our polynomial
This includes the study of both finite
then
and
at least
infinite
one of the two
sets.
factors must be zero.
Special attention given to infinite
This
sets.
algebraic
It
phenomenon
led us to the development of
first
concepts
verb
like
as
partitionality, which measures the size or number of elements in one set. Plus,
It is
set theory explores the properties
geometry
and
of whether the curve is
implications
zero.
of different
Appearing
axiomatic
in the
systems,
algebra.
such as the Zermelo-Frankel axioms.
The curve y
These
squared
axioms
equals
are
x squared
foundational
times
for
x
all
plus
mathematics,
This could
and they define the rules
And
by
as you
which
know,
sets can be constructed and
can we
manipulated,
detect this using algebra?
and
小
include
明
the
建模
axiom
看起来
of
才会
choice.
出
Let's bring all the
It
terms
has
to one.
implications in many fields of mathematics.
你看小明也不错啊，他脑子看起来也不错啊，能力
Notice
也不
that
错啊
these。two functions are
那
both
不会
model
不好
theory.
吗？看起来也棒棒的啊，又怎么了？
product
Logic and model theory
is
use
zero.
formal language in order to define and study mathematical structures. It allows us to understand how these structures follow
这个小
rules
小
and
看起来偷
axioms.
色吗？
The study emphasized the relationship between sympathetic approaches,
偷色你这
which
种
are based on the formal language
当然是啦。
and semantic views,
is a
这个教练不是有什么那个叫什么爱撸爱撸管爱撸铁的
Model theory address fundamental results such as the completeness and incompleteness theorems.
爱撸
The completeness theorem tells us that if a statement is true in all models of a theory, then it can be proven within that theory.
爱
The incompleteness theorem demonstrates that no consistent set of axioms can prove all the truths
官
about
方
the
是
phenomenon.
用色体主播吗？是吗？
now
色体和赛特，官方是用赛特主播啦，是吗？还是偷色？
this is defined as a set of formal powers
Stochastic process.
with R.
中国的翻译那个时候他们叫什么？官方
Branch
色体主播，
examines
色
the
体就是赛特
mathematical
主播，
models
他们官方是用的主播吗？官
influenced
方
by
是用的偷
random
色。
variables or signs. This field is super important in understanding phenomena where outcomes are inherently uncertain and can evolve in complex, non-deterministic ways.
对，说就说，先不要列队，哎呦没关系，反正一边玩这个约略一边那个就是脑回然后一边看看
The curve has
This
You
field
don't have
mostly
HCM on
uses
top.
probabilistic methods to model and analyze algorithms that involve uncertainty and randomness.
well,
Specifically, it focuses on transitions and changes that occur at critical points.
先把你先关起来，后面还有吗？
if you look at most textbook calculus geometry, most proofs use ring theory.
播完差不多到。
High-dimensional geometry and its probabilistic analog.
And I ask you, what are
The
the
field studies the properties and behaviors of geometric objects in spaces of high dimension, where objects that appear different in lower dimensions can show similar probabilistic properties.
that are captured by the coordinate?
They introduced the isogeometric principle,
要玩
which in high dimensions has an interesting connection.
哎，可是那个游戏里面他们有漏篮，有些有漏篮板球，那可以。有看上面
Honestly, this list could be endless. It is impossible to actually map all mathematics, but as a general layout,
But can we reverse the test?
notice that we focused mostly on pure mathematics. We did not talk about its implications like physics, computer science, economics. We're sure that there is way more that can be added, but hopefully this gives you a pretty good idea of what kind of foundations and branches there are. Let us know in the comments what other fields should be included.
This video was based on the Princeton Companion to Mathematics. Link in the description. If you like this video, I'm sure you're going to love this one. See you guys later.
Mathematics is built on very important areas like geometry, calculus, algebra, real analysis, and concepts. But these fields can all be broken down into specialized branches of mathematics, which can be in one specific field or shared by many. Let's go through every one of them. Algebraic numbers. This branch explores the properties and relationships of complex numbers that satisfy polynomial equations with integer
Returns the value
coefficients.
1,
Algebraic numbers include all rational numbers, so roots of unity, and it has two solutions to polynomial equations like this one, where the coefficients are integers.
it's a
Algebraic number theory studies many kinds of structures and systems that can be derived from these numbers, like number fields and ring properties. The theory also goes into ideals, units, and the unique factorization of ideals through rings of algebraic integrations.
An important ingredient
Analytic number theory.
required showing that certain
Analytic number theory mostly focuses on approximations rather than exact solutions. It involves the deep analysis of number distributions, specifically primes. This branch of number theory does not expect exact formulas for most of its quantities,
a really good starting
unless they are artificially constructed. Computational number theory.
It's written in a really
This
elementary
branch of
style
number
and has
theory
lots of
focuses on
captivating
developing
diagrams.
algorithms to solve
If you look at the
numerical
table of
problems
contents,
related to
starts off with
integers
a
and
lot of
other
examples
number
that
theoretic
require mainly
methods.
elementary high school level algebra.
It involves the creation and application of computational methods to perform calculations of large numbers, such as factoring integers, finding primes, and computing discrete logarithms.
Ideal variety and algorithms. The great thing about this
Abstract algebra.
doesn't assume any knowledge of abstract algebra.
Abstract algebra examines the properties and structures of algebraic systems like groups, rings, and does so through concepts like homomorphisms, isomorphisms, and ideals.
It is
It
very
includes
tricky.
many
It is
sub-branches.
attractive, but it has everything in it and it is written very, very well.
Category theory.
If this is your cup of tea, by all
The
means,
main idea in category theory is to focus on relationships between objects rather than the objects themselves. A category consists of objects and morphisms, also called arrows or maps of unique objects. Morphisms can be thought of as processes or transformations from one object to another, and they satisfy properties like associativity and the existence of identity
看人家
morphisms.
8几个拿球棒打折，你去哥打，包是傻小。有人说什么二手帕梅拉那个掉价掉了30-40万，这30万
Algebraic geometry
还包傻小。人家是
studies
球棒打折，你
properties
结
and
束了。
relationships of geometric structures that can be described algebraically through polynomial equations. This field combines abstract algebraic concepts such as rings and fields with geometric equations.
这么好，那我就买一台来开了。
Linear algebra.
they're curves that are cut out by polynomial equations.
This branch studies vector spaces and linear mappings we
It's
can down.
defined by the algebraic equation.
It focuses on understanding systems of linear equations, matrix operations,
神病不能考驾照，
eigenvalues, and
神病可以
eigenvectors.
考驾照，要看技能升到什么程度，好不好？
Using these linear
说我这个道
algebra
具认真的有没有会考得到我？
spaces and differentiations that preserve their linear
考
properties.
驾照吗？
But why? Because algebraic geometry is not just
Arithmetic geometry.
那你有驾照吗？
The subject
有体
mostly
检的时候会不会
deals
过不
with
了？
the
因为我不
offensive
能当
problems, which are equations seeking integer or rational solutions, and explores how these can be manipulated through geometric principles.
is that under you should study functions.
Arithmetic geometry makes use of advanced algebraic concepts such as schemes,
不能吗？
algebraic
要
topology.
生不如的。
It studies spaces through algebraic structures known as topological invariants, such as homotopy and homology groups. The goal is to assign algebraic structures, such as groups, rings, and vector spaces, to topological spaces. This helps to classify and distinguish these spaces based on their topological properties.
3 over root 2. We would map this point to -1 over root 2.
Differential
人家球棒
topology
手会不会当成教练
is
车？
field that focuses on studying properties of geometric structures that are preserved under squares. Specifically, within the context of manifold. The essence of differential topology involves examining the local properties of manifolds by using tools or calculus,
Is 3 over 2.
by ensuring that the transition functions between local coordinate charts are smooth. Infinitely differential. Differential topology allows for the comprehensive application of differential and integral calculus
They are the same as functions of units. More generally, any function of this form will be the same as the other.
Differential geometry.
The set of polynomials
Differential geometry is the study of smooth shapes and structures.
denoted
It uses the tools of calculus and linear algebra to explore the properties of curves, circles, and higher dimensional
前期
maps.
的歌
polynomials with real
Key
coefficients.
topics include curvatures, geodesics, and connections, also with strong links to topology, analysis, and even theoretical physics.
Now look at this deck. All polynomials.
Modalized spaces.
这怎么的啦？
Modalized spaces allow for the geometric classification of objects like curves, surfaces, and more abstract structures, but treat them as
都这样。
in geometry. The approach of modalized spaces simplifies their understanding of these objects and makes their manipulation much easier.
谁？
For example, modalized spaces of curves help in exploring how complex structures like a human circle or bears can interact under continuous
Algebraic. Alongside, for those who know
representation theory.
realize that there is working with quotient.
The main idea in representation theory is